Hello once again. Today we are going to be covering the topic of wheel cylinders. Now the first thing we should do is define what a wheel cylinder is and where you will find it. A wheel cylinder is a mechanical device that takes hydraulic pressure from the brake system, and as fluid enters a chamber, it is applying the brakes. Now the type of brakes that are unique to using wheel cylinders are the drum brakes. This is an example of a drum brake. This is our backing plate, which faces the inside of the vehicle. We have our friction material on either of these two pieces, each of them called a shoe. On this particular model, part of the backing plate here is our anchor. The location of this anchor is going to be important for getting into more of the understanding behind drum brake. What I want you to pay attention to here is right up on top, this cylinder located at the wheel. This is the wheel cylinder. Its job is to push these shoes, these linings, outward. Now, some of you may have had experience with mechanical brakes, such as on a bicycle or a motorcycle. So I have an example here. This is a 1979 Honda Twin Star. The front brakes on this have a drum brake assembly. And when the brake lever, the handbrake lever here, is squeezed, we have motion down here at the drum brake. So as I squeeze the lever, the cable, mechanical motion, actuates an arm or a lever. What this is doing as it pulls on this lever is the inside, as this lever is turned, these shoes are being moved outward. Because of ramps that we have on this center piece here, as it rotates, it's going to push those shoes outward. So what are those shoes trying to press against? On this example, when you look at the drum brake assembly on a vehicle, this is where the back of the wheel would rest right here, and you'd have studs or lug nuts or lug studs, wheel studs coming through, and this is actually being held in place by the torque of the wheel studs or your lug nuts. So with this removed, this is our drum brake assembly. Now on the inside of this drum, and it's kind of like a bell shape, and they do ring like a bell, and we'll get to that in a bit. But this machine surface here is what those shoes are pressing against. So the job of the wheel cylinder is to take hydraulic pressure rather than the mechanical version that we saw from the motorcycle. It takes hydraulic pressure and pushes these shoes outward to the inside of the drum. Now, wheel cylinders can be slightly different designs, but their general principle is the same. Here's an example of a wheel cylinder from all sides. This right here is our mounting surface. So we actually have some bolts that will fasten this to the backing plate and anchor it in place to where it can be held steady and there's no fatigue on the lines. Now this little piece right up here, this is our bleeder valve, and it's important that this is going to be on the top of the wheel cylinder when it's installed. The reason we want it on top is because our brake fluid is going to be coming in through this port down here. Now just to show you an example of a different one. Slightly different, same idea. The bleeder screw would be up here, and the brake line would allow fluid to enter down at the bottom. The reason we want the bleeder located at the top is so when we have air trapped in the system, air bubbles are going to rise to the top. So we can open the bleeder valve during bleeding or flushing and allow the air to be purged out of the system as new fluid comes and replenishes from below, thus eliminating any air pockets. The problem is if we have air in that system, that air is going to compress. and we won't be able to actuate the brakes to their full potential. These boots here, they don't seal anything. They protect the inside of it from dirt and other debris. So this is just a dust boot. Now on this particular application, these would have a push rod that is actually held in by the inside of this, just keeps it retained a little bit, and the piston is inside of the bore here. So as we take this apart, we have a dust boot on each side removed. Now we can see our piston on either side. Here's one piston, just a flat piece of aluminum. With the dust boots removed, we have a piston on each side. Now notice the difference in profile between this side of the piston and this side. The side that is not flat is the side that points outward. So this goes to the outside of the body. So it goes in just like that. Now behind the piston is a cup seal. The cup seal has a flat surface on it. The piston has a flat surface on it. Those two are mated together. Now this cup seal, I don't know if you can see that, it's a bit of a conical shape, or almost like a wedge. There's a taper around the seat here, and it is shaped like a cup. The reason behind this is as fluid enters and fluid pressure builds on the inside of this cup, it's going to put pressure into the face of it, and equal and undiminished in all directions, it's going to be pressing outward against the inside, so furthering our sealing ability on the inside of our bore. Let me push the other side out since they're the same on both sides. So on our bore, it's important that we have a nice smooth surface on the inside here. So our cup seals can seal against that surface and move back and forth inside and out without allowing fluid to leak. With the system sealed, we keep the fluid in place and the brakes function. Now when the brakes are at rest, we have a spring inside, and these may be attached to or not attached to these conical shaped pieces on the end. This is our cup. This little piece right here is our cup expander. So when this is sitting inside the wheel cylinder, both sides are being pushed together by the shoes. So the pistons are pushing these things together and squeezing and putting tension on that spring and tension on the cup expander. And the cup expander does exactly as the name suggests. It is taking that pressure, and without any fluid pressure inside, it is using mechanical force on this tapered edge to help push the seal against the wall of the bore. So the cup is actually being held in a sealing force against the inside of the cylinder bore and the inside of the wheel cylinder. That way, when our vehicle is parked, it is not leaking fluid. A couple other things to note here. Here's a cross section. You see one hole, see another hole. Also, what you can tell from this is that we have a nice clean surface coming all the way in, but there's a point in here where it's a little discolored. It's discolored because our seals don't ride all the way to the middle. There's a point at which they stop. So with our cup expander and our piston, there is a point where these will be pushed together from both sides and that piston doesn't go in anymore. So when we're examining the condition of a wheel cylinder, we want to make sure that we have a nice clean surface area here for the cups to seal against without there being any divots or corrosion, rust, or pitting on that sealing surface. It's okay if we have some on the middle where we don't have any sealing occurring. Now, if it's bad enough, the wheel cylinder needs to be replaced, but in a lot of cases, it doesn't necessarily matter if there's corrosion, pitting, or corrosion on that middle section there. So you can kind of see where that discoloration is towards the middle there. So 2 holes, one for the bleeder up top, one for the inlet for the fluid to come into the wheel cylinder. Anytime one of these is replaced, you're going to inevitably have air pockets, and then bleeding the air from the cylinder is going to be the final step before making sure that the rest of the system is in working condition. One part about rebuilding these is honing. So taking an abrasive hone and rotating it with the drill and moving it in and out as it's spinning on the drill. The idea is to clean up any corrosion that there might be, and this one has a little bit of corrosion. I'm not sure if you can tell. Try not to blind the camera here. You can kind of see a little bit of rust. Little bit. Just a little bit. But that oxidation is going to provide a path for fluid to leak past the cup seal. And with rust, it will continue to oxidize more of the metal. So we have to get rid of all the rust. After disassembling and assessing the interior condition of it, we can determine whether or not it should be rebuilt. Now, theory versus reality. What's going to happen in the real world? Typically, if you have a leaking wheel cylinder, these are going to be about $7 to about $20 a piece at a cost level, so they're very economical to replace. The other factor is, what is it made out of? A cast iron or steel wheel cylinder can actually handle the abrasive contact of the hone passing through it. It's not going to take off too much of that surface area. So as it does remove enough material to restore the sealing surface to like new condition, it's not going to remove so much to where our cup seals can no longer make a good sealing contact with the wall of the cylinder bore. Now, if it's made out of aluminum is much softer than steel. It's lighter weight, so there may be a reason for it being used. Very popular on front-wheel drive sedans that are more econo-based. The steel ones are more heavy-duty. Think about a Cadillac or a truck, something like that that's a little more robust. With a lighter-duty vehicle, more economical, anywhere they can shave weight, they're going to do that from the manufacturer standpoint. So weight savings and cost savings. That may come down all the way down to wheel cylinders. So if it's made out of steel and the pitting inside is not bad enough and it's only on the surface and you can find parts to rebuild it, you can rebuild them. Otherwise, most of the time you'll be replacing them, even the steel ones. Another situation would be availability. Whether or not the wheel cylinder is for a model of vehicle that has parts readily available to it or for it in the aftermarket, or maybe it's from, it's an odd VIN or a VIN split year where they change things and there's just no parts availability, or you're doing a restoration. Bottom line, it's rare that you have to rebuild one of these due to lack of availability. Braking systems are a safety system. Brakes are the most important system on your vehicle as far as safety is concerned. So a lot of them are available. So for the purpose of this class though, if you were to rebuild it, those are the things to look out for. Now, reassembly on the wheel cylinder. Here it is. open, all clean. You can use brake fluid as a lubricant. I wouldn't use anything besides brake fluid, since brake fluid will be in the system. If you were to use something that is a lubricant that does not work with brake systems, then you may cause damage to the seals, or you may introduce some of that and mix with the fluid later on if you don't get it all clean. Typically, if you are reassembling, you won't be getting anything out of there. So only use brake fluid for lubrication. The type of fluid that you use is also important. Just use the brake fluid that the manufacturer specifies to use. So, one seal in here, flat side facing out. Cup expander and spring gonna go in next, so we can put in our opposite side seal. And we just want to carefully work the edges of that around. We don't want to use anything sharp, and we don't want to force it. What we don't want to do is fold the lip or tear the lip while we're installing it. Any tears or folds is going to be a leak. So once that's in there, we can push that in a little ways. And now our cup seals are installed, and I just pushed them down towards the middle, so it's about where they're at. So they are sealing right up to about this far into the cylinder bore. Next, we have our pistons. Divot side faces out, flat side faces the flat side of the cup seal. That goes in next. Now, should there be any fluid on the actual piston itself? The answer is no, because our cup seals are keeping all that fluid sealed in the wheel cylinder. So piston on each side, and we can give it a little squeeze, make sure everything's moving around in there. And then finally we put our dust boots back on. Your rebuild kit will come with all new rubber material, because these often get torn or deteriorate over time. So just work it around until it's back on there. And then we have our wheel cylinder that is ready to be installed as if we were just replacing it. So now that we've discussed a wheel cylinder, what it does, where to find it, and how it works, I will show you the original example that I showed you before with our wheel cylinder up on top of our drum brake assembly. And if I flip this around, you will see the two mounting holes right here, or the two fasteners that mount it. This threaded piece right here is where the brake line would allow fluid to enter. And then, just as it should be protected, this little rubber dust cap is covering the bleeder up top. So this is the correct orientation. It's above, so air can rise up and be displaced by the new fluid coming in. And once all the air is removed or mitigated from the system, we have a functioning wheel cylinder that's ready to work again on a brake assembly. Now, most vehicles that you'll work on don't have they don't have front drum brakes. You may come across it if you're working on something that's old enough, but typically you're going to find these on the rear of some vehicles. Even rear drum brakes are being phased out currently, but there are plenty of vehicles driving around that have rear drum brakes. They are still commonplace. So good information. Heads up on this example. This is an example of an aluminum body. So this one, if it were to leak, would not be able to be rebuilt. It would have to be replaced. In addition to that, there are some notes on here. There's an L for left side, and then 11/16 stating the size of the bore. So this is an 11/16 inside diameter, and it's for the left side. Now, why would it be important, left side versus right side? If we put the bleeder facing up, that's all we need to do. But in this example, we have vertical mounting fasteners, and they are on the opposite side from where the line enters as to where the bleeder is. You can see these two faces right here. One is drilled for the line coming in. This side, this was likely molded for either side, and then when it came time to machine it, the machining process machined this side for whichever side of the vehicle this was supposed to be on. So if this was a rear brake assembly, this was facing inward, this body facing outward from the axle. The line is going to be coming from the front of the vehicle. So this would likely be a left rear wheel cylinder. So as we position this, the line is going to come from this direction. This is going to be the outside, so we'd be on the rear left. So pay attention. Before you remove a part, look at your new part. See if it matches. See if you have two lefts or two rights. If you have identical ones, they should be symmetrical. They should not be asymmetrical like these. If you have two exactly the same, you have either two lefts or two rights. So pay attention to some of those details, and it'll save you a lot of headaches in the future. So this was wheel cylinders. If you have any questions, please email them to me. And I would love to address any questions with either the whole class or individually. Thank you.